Hello guys, welcome back. Today we saw a medium one, that is snake and ladder. The statement gives us a metric called board, where the cells are labeled from 1 to n square in the cultural style. That's when you write in you alternatively reverse in each every new rows. That is raise and y in the reverse order, and then y in the straightforward order. Okay. You start on square one. In each row, you can move to slide to curve q1 to -1 or up to curve +1 or curve +6. This just simulates the result of the standard size dice roll. Okay. That's when you have a dice and you roll. That's may appear a number from 1 to 6, and you move to the next one of the next six cells. Like one can move to from the cell one can move to 2, 3, 4, 5, 6, and 7, like that. If and remember, you you can't move outside the board, right? If next had a snake or ladders, you must move to the destinations of that snake or ladders, otherwise you move to next. That's when, for example, you move to 2, like from 1 you move to 2, like you maybe you must follow the ladder and jump to it's going to be 15, right? Or for example, you reach the 17 here, you must then jump to the 13 here, okay? And I think we need to note here is that you only take a snake or ladder at most once per gyro. If the destination to a snake or ladder is the start of another snake or ladder, you do not follow the subsequent snakes or ladder. That means, for example, if 15 here have a snake or ladder to like to 34, you must you can't jump from 2 to 34, but you must go somewhere, then you can back to that. For example, like you can jump to 15, then you go to 17 and back to 13, and you jump to 15, then go up to 40 at 34, like that. Okay. Let me no. Um, this is a typical BFF problem. Yeah, as we know that this week is on about that problem. So let me draw some example like this. Okay. So like that, and this we have for each for type force magic, right? And think just like graph, you can move from a cell to the next six cell like this. You can see that you can jump to the next cell 1, 2, 3, 4, 5, 6, like that. Okay. 7 here you can jump to this, and for example, if we have a ladder, like for example, we have a ladders snake from a cell to another cell like this. Okay. So you can do something like we know that if you move from 1 to 2, you can immediately jump to the cell this cell, right? Then you can draw an edge like this with the zero cost, or simply you can draw something like directly right from with this to this cell. It's called 1, right? Because you can jump from 1 to 2, then immediately jump to like this cell. It's the same as from the first cell to that cell to that's okay, we call it square or cell, whatever. That is, we need to build a graph based on this given input. Like you see a board as is represent the destination of a snake or ladders. For example, the two here we can is a 15, because from the cell 2 you can jump to cell 15. So that is just a DFF solutions by the short path with the edge to the short the, the, the minimum edge you cross by. Okay, so just implement and BFF here. Okay. vector to store this thing to vector in and 0 minus 1 like that. And minus 1 means we didn't visit it before. So the cell minus 1 0 we start as cell we start at the cell first it is the first the last column, that's row, and the first column yeah is above minus 1 0. We push this into this cell into queue and do a def sign, pop it out. One is we top prompt pop out. So if h we need to write function to get the cell, the value still get value from positions and right and we can see that first we need to do something like this. It's one reverse order. Yes, we can think it as it is this the 1 2 3 4 5 6 reverses, and like if h is something like this is odd, that means like first this row and this row and this row is in the like straightforward order from left to right, so we can return h minus multiple by h equals y. Y if it's even, it's maybe in the reverse order, so we take this one and we need to first in the reverse order, and we use n minus y and minus 1 in the reverse order. Well, actually we must plus 1, and here we don't minus 1 because we index from the label is from 1, but the index from 0. Let's take an example as this cell 9 we got 9 is the row 1 in the reverse order, so over 6 plus this is the right 1 2 3 4, the fourth cell we got 6 minus 7 3 fourths, it means the index is 3, you know 1 2 3 4. Okay, we got the 9 here, as you see. Okay, if get value of y and is the last the target cell square, we return this from this, and if not we return minus 1. We can find a path from 1 to that cell, but there's only the way, I believe so. If and we need to for value you can see something like from 1 to 6 at last the side each side of the dice roll, and like in estimate value is value plus 1, and like estimate value is last the last step, so we need to break out this board, okay, because we can reach outside the board, right? Okay, that now we need to convert it to the positions, so let's write function like value to pose this way. Write a function like that. Value to position is from the value. For example, the cat 15, it must return like 1 0 1 2 3 3 and 3 and 2. Okay, it's like that value. And first we need to calculate h must be like value divide minus 1 because we think that's from 0 minus 1 and divide by n, and that's we got the rows in there. For example, the 15 we divide by 6 at 15 minus 1 divided by 6, we got the 2. Okay, that is 2 from bottom to top, right? And for example, this 26, 12, 20s, we got 1, okay, and like 30, we got 2, like that. If it's odd, just simply return something like so, y is y less minus 1 mod n to get the reminders. For example, the 11, the 11 minus 1 and no 6, we got 4, but it is in reverse order, so we must reverse it by lay n minus it. So if h it is so we reverse is I is 1 to return h. That is, so we got these functions and check it out here. Both uv is even from -1, that means there's a ladder or a stack to jump to another destination. So we must to like from value to process like for uv, both uv and view, we must do this, and I describe in this image in the demonstration here. You can jump directly to that position. Right. Okay. If like there's uv is a -1, that means we have not visited this cell before, so we do increasement in this number of steps, just push it to the queue as a debug algorithm. Check it out. Queue push on this queue. Value to post well, wait a minute. Just wait a minute. Just let's debug here. Let's debug here. Okay, see that the get value is wrong. Okay, that must be like minus is reverse is the order is multiplied by n, and got something wrong here. That is removed from -1 hy. -1 is the oh, that's what was wrong here. You see that 501 and we got to the next cell. Oh, maybe this function is wrong. Let me check it out. This is correct, and this is correct. This is may not correct. Oh, it's not. 01 return 55 is not correct, and we don't jump to this cell. Okay, there's that maybe the cron no minus 21. That's mean. Sure, this must be in reverse order. Okay, in reverse order. Check it out. Okay, that's 9 day. We'll see you tomorrow.